This video covers Lesson 7-1 for Secondary 1 Math, Simplifying Radical Expressions. Simplifying radical expressions can also be thought of as finding the square root of a number. When finding the square root of a number, we're really asking what number multiplied by itself is equal to the number inside the square root sign. Okay, so for example, we have the square root of 16 here, and that's asking what number times itself is 16. Well, 4 times 4 is 16, so the square root of 4 times 4 is 4. So 4 is the number. So to answer the question, what number multiplied by itself is equal to 16, we would say the answer is 4. This works great for taking the square root of a perfect square. But what about the square root of 20? It's not going to work out very nicely. So the first thing we're going to do, and for these first 4 problems, we're going to practice finding the prime factorization of any number. Number 1 gives us the value 45, and we're going to find the prime factors, or do the prime factorization. And to do this, we create the tree. So what number times what number is 45? Well, we might think, oh, let's see, 45, that's 9. And 5. So 9 times 5 is 45. But 5, this is a prime number. Nothing but 1 times 5 is equal to 5. But 9, we can factor down to 3 and 3. So 3 times 3 is 9. Now 3 is also a prime, so here's our prime factorization. So we write this as 3 times 5. Or you could put it as 3 squared times 5. Finding the prime factorization of 56 in number 2, we're going to see 56 is, well, it's even, so 2. 2 times what? Well, if you're not sure, do 56 divided by 2 in your calculator, and you'll get 28. So make sure you can do that. Then 28 can be factored to 2 and 14. 14 times 2 is 28. And 14 can be factored to 2 times 7. Now 7's prime, 2's are prime. So here's our prime factorization. We're going to write it out. So we have 2 times 2 times 2 times 7. Or using exponents, we can write it as 2 to the 3rd power, because we have 3 2's being multiplied together, times 7. Number 3, 240. So again, prime factorization. The nice thing about this one is it has a 0 at the end. So we can factor a 10, because anything times 10 is going to have a 0 at the end of the number. So we got 24 times 10. Then factoring down 24, we know it's even, so we can divide by 2. So 24 divided by 2 is 12. So 2 times 12. 2's prime. 12 factors to 2 and 6. 2 again is prime. 6 factors to 2 times 3. Then we have the 10, which factors to 2 times 5. And 2 and 5 are also prime. So now we're going to list these for our prime factorization. So we have 2 times 2 times 2 times 2 times 3 times 5. And let's see, there's 1, 2, 3, 4 2's, which I have, and a 3 and a 5. So, or we could write it with exponents and say it's 2 to the 4th power times 3 times 5. Okay, now finding the prime factorization for number 4, we're going to factor this to 10, because it ends in 0, 10 and 55. Now factoring 55, that's 5, because it ends in a 5, or a 0, it's divisible by 5, and 11. 10 factors to 2 and 5. We can't factor these anymore, okay, because 5, 11, and 2 are all primes. So this would be 2 times 5 times 5 times 11. Or we can write it as 2 times 5 to the 2nd power, or squared, times 11. And this is how we find the prime factorization of a number. Okay, so we're going to use this prime factorization of a number to help us simplify each radical expression. To simplify each radical expression, we're just going to find the prime factorization of the number inside the square root first. So 54, we're going to find the prime factorization. So we have 2 and 27. 2 is prime. Keep factoring the 27. So this is divisible by 3. So 3 and 9. So 3 times 9 is 27. And 9 is 3 times 3. So now 2's and 3's, those are primes. So we've found our prime numbers. So we're just going to write this prime factorization inside the square root. So we're going to have 2 times 3 times 3 times 3. Now, to simplify the square root, we're looking for what number times itself gives us the number inside. Well, we're saying what number times itself. Can we see a number that is multiplied to itself? Well, right here, 3 is being multiplied to 3. So we're going to get a 3 outside the square root. Then left inside our square root is this 2 and 3 not circled. So 2 times 3 is 6. So the simplified radical expression is 3 root 6. Number 6, the square root of 12. So first, we're going to find the prime factorization. So 12 goes to 2 and 6. 6 factors to 2 and 3. Well, 2's and 3's, those are primes. So we have 2 times 2 times 3, all in a square root. And we look for pairs. So here's a pair of 2's being multiplied together. So we're going to get a 2 out of our square root. And then we're going to have 2 square roots of 3. And that's our simplified radical expression. Number 7, the square root of 48. So again, we're going to do our prime factorization. So 48, that would be 2 and 24. We'll factor 24 down. 2 is prime. That's 2 and 12. 2 is prime again. 12 is 2 and 6. And 6 is 2 times 3. So now that we have them in our square root, we'll have 2 times 2 times 2 times 2. So there's 1, 2, 3, 4 2's. I got 4 2's times 3. So now we want to simplify, so we're looking for pairs of the same number. So we have 2 2's being multiplied together, 2 other 2's being multiplied together. So we're going to get a 2 and a 2 out. So we'll have 2 times 2, and still inside the square root of 3. 2 times 2, though, we're going to simplify that. So we get 4 root, or square root 3. And that's our simplified radical expression. Now you might be asking yourself, why do I have to do this? Seems ridiculous. I can just put it in my calculator and get a decimal. Well, the one thing we have to remember is that when we get that decimal in our calculator, it goes all the way to the end. It's actually an approximation of the value. So if we say the square root of 12, I type into my calculator and get this long decimal, it actually is an approximation because the square root of 12 is an irrational number. So this goes back to irrational, rational numbers. It's an irrational number, meaning it actually won't be that number exactly, but it'll be close enough for our calculator to say, hey, this is about what it is. So when we simplify each radical expression, we're getting an exact same value, whereas if we put it in our calculators and get a decimal, it's an approximation. So let's go ahead and move on to number 8, the square root of 21. So first we're going to find the prime factorization of 21, which this factors to 3 times 7. And 3 and 7 are both prime, which means we would have the square root of 3 times 7. And there's no pairs of numbers being multiplied together, so we can't do anything with this. This is already a simplified radical expression, so we're going to rewrite it just as it was, the square root of 21. Number 9, the square root of 108. Again, we're going to find the prime factorization of 108. So factoring this, we have 2, and half of 108 is 54. So we have 2 times 54. Factoring down 54, we could do 2, since it's even, 2 times 27. Factoring 27, we get 3 and 9, so 3 times 9 is 27. And then 9 factors to 3 times 3. So now we have prime factors. So writing this in our root, our square root, we have 2 times 2 times 3 times 3 times 3. Now we're going to circle pairs so we know what we can get out. So 2 times 2, that happens there, so we're going to get a 2. Then we have 3 times 3, so we're going to times 3. But there's only one 3 left, so that stays inside the square root, so square root 3. So simplifying that, 2 times 3 is 6, so we're going to say we have 6 square root 3. And that's our simplified radical expression. Number 10, the square root of 306. So the first thing we got to do is find the prime factorization of 306. So 306 is an even number, so we can do 2 and, well, if we take 306 and divide it by 2, we can find what we have to multiply 2 by to get 306, which is 153. Then we're going to factor 153, and it's not even. It's not a 5 at the end of the number. So let's go ahead and try dividing it by 3. So in your calculators, put 153 divided by 3. Once you've done that, you should get 51, which means this is 3 times 51 is 153. So again, 51. So it's not even, so 2 is not going to work. It's not 5 or 0, so 5 is not going to be a factor. Again, try 3. So 51 divided by 3 in your calculator. And that gives us 17. So 3 times 17. And well, 17 is prime as well. So our prime factorization of 306, or the square root of 306, is the square root of 2 times 3 times 3 times 17. Now we're going to look for pairs of the same number. So 3 times 3, there's a pair of 3's being multiplied together. So we're going to get a 3 out of the square root. Left inside we have 2 times 17, which is going to give us 34. So we have 3 root 34 as our simplified radical expression. Okay, number 11, we have the square root of 324. So again, the first thing we do is we're going to find the prime factorization of 324. Since 324 is an even number, we know it's divisible by 2. So 2 could be a factor of 324. And if we take 324 and divide it by 2, we get 162. Now 2 is prime, 162, we need to factor down. And it's even, so we're going to divide by 2 again. So 162 divided by 2, and that gives us 81. So this is not an even number, 81, but we can factor it. 9 times 9 is 81. And then 9's factor to 3 times 3. So we have our prime factors, 2, 2, 3, 3, 3, 3. Now we're going to write our prime factorization underneath the radical. So we're going to have 2 times 2 times 3 times 3 times 3 times 3. So we have a pair of 2's, right here being multiplied together, a pair of 3's, and another pair of 3's. So we have 2, 3, and 3. So we're going to have 2 times 3 times 3. And there's nothing left inside the square root or the radical. So we don't need to write that radical. We're just going to do 2 times 3 times 3. And 3 times 3 is 9, times 2 is 18. So this is 18 as a simplified radical expression. Number 12. So we have square root of 600. We're going to do our prime factorization of 600. So 60 and 10. 10's nice because it ended in 0. And 10 factors down to 2 and 5. 60 is going to factor to 6 and 10. And 10 again is 2 times 5. And 6 factors to 2 times 3. So now we're going to write our prime factorization underneath the radical or square root. So we have 2 times 2 times 2 times 3 times 5 times 5. Now let's just check that. We have 1, 2, 3 2's, a 3, and then 2 5's. So now that we have it written out, we're going to find pairs. So we have a pair of 5's multiplied together and a pair of 2's. So we're going to pull out a 2 and a 5, so 2 times 5. Then we have the square root of 2 and 3 inside, so 2 times 3 is 6. So our simplified radical expression is 2 times 5, which is 10, so 10 root 6, or 10 square root 6. Number 13, we have the square root of 255. So first we have to do our prime factorization of 255. And the first one I would use is 5, since 255 ends in 5. And if we take 255 and divide by 5, we get 51. Now, factoring 51, it's not even. It doesn't have a 5 at the end, so we're going to try 3. So take 51, divide it by 3, and we'll get 17. So 17 is prime, 3 is prime, 5 is prime. So we're going to write this in our square root. So we got 3 times 5 times 17. And I'm looking for pairs that I can circle. And since there are no pairs of the same number in our square root, we're just going to write this as the square root of 255. And that is the simplified radical expression. This concludes the video of Lesson 7-1 for Secondary 1 Math.